Hello everybody. So today we are going to be looking at ratios and proportions. A ratio is a comparison of two numbers by division. So if I have two numbers, let's say 3 and 8, that is going to look like 3 to 8. You may also see it written like 3:8, or you might see it as 3 to 8. But most likely in the math world, we will be writing our ratios like a fraction because we're comparing 3 and 8 through division. So write a ratio involving the following situation. A person makes 6 long-distance calls and 15 local calls in 1 month. So find the ratio of long-distance calls to local calls. Well, they made 6 long-distance calls and they made 15 local calls. So if I compare those two, I have 6 over 15, which I can then simplify. I can simplify that fraction if I divide a 3 out of both of them to 2 over 5. Okay, so for every 2 long distance calls, you made 5 local calls. Now, the next question is asking us to find the ratio of long distance calls to all the calls that were made. So they made 6 long distance calls, and they made 6 long distance and 15 local calls, so they made 21 total calls. So if I set up that ratio, 6 to 21, then if I simplify that, I'm going to get 2 over 7 because I can divide 3 out of both of those. So this over here is the ratio of long distance to local. Here is long distance to total calls. All right, and the reason we need to know what ratios are is so that we can set up proportions. A proportion is an equation stating that two ratios are equal to each other. So if I go back one slide, what is boxed together? Those are actually proportions because those are stating that the two ratios are equal to each other. So what ratio forms a proportion with 12 over 15? Well, if I simplified 12 over 15, if I simplified that fraction, then I was going to get 4 over 5. Okay, so that is one proportion that I could have. 12 over 15, if I multiplied both the top and the bottom by 2, and I got 24 over 30, that would be another example of a proportion. So if I want to determine whether ratios are equivalent, like in this next example, all I need to do is take both ratios, break them down, so I need to simplify these fractions, and then see if I know if they're the same fraction. So I know 5 goes into both of those. So 45 divided by 5 is 9. 75 divided by 5 is 15. And then I know 3 goes into both of these. So 9 divided by 3 is 3. 15 divided by 3 is 5. So let's see if 18 divided by 3... let's see if 18 over 30... Sorry about that. Let's see if 18 over 30 simplifies to 3 over 5. 18 and 30, 6 goes into both of those. So 18 divided by 6 is 3. 30 divided by 6 is 5. So since these are the same, yes, they form a proportion. All right, so I'm going to skip B for right now because I want to go over to our main part of the video, and that is solving a proportion. So you can solve a proportion because if you look at the problems below, you'll see they look similar to things that we have been doing, where we have an equation involving a fraction, and so we need to multiply both sides by the reciprocal. But another way to do it is to solve using cross products, or by doing cross multiplication. So the way we have been doing it is, like, if I look at question 1, I have x over 10 equals 3/5. Well, what's happening to x? It's being divided by 10, and so I need to multiply both sides by 10. that's going to cross cancel on the left-hand side, leave you just with x. And then if I cross cancel on the right-hand side, I'm going to get 3 times 2 equals 6. So that would be what x equals. To do cross multiplication, I'm going to have x over 10 equals 3 over 5. And I'm going to cross multiply here. So I'm going to multiply across the equal sign on the diagonals. So 5 times x gives you 5x. You drop the equal sign, and then I get 3 times 10, which is 30. And then to finish this out, all I need to do is divide both sides by 5. So x equals 30 divided by 5, which is 6. Notice how you got 6 in both ways that you can solve this problem. Now, when I look over at number 2, when it's a little bit more complicated, I want to go to using cross products. So if I use a cross product here, I'm taking 10 times this whole thing, 4v plus 7. I drop my equal sign, and then my other cross product, I've got 15 times 6v plus 2. I'm taking 15 times that whole thing. And then what I need to remember to do now is to distribute my numbers. So 10 times 4v, that's 40v, plus 10 times 7, which is 70, equals 15 times 6, which is 90v, plus 15 times 2, which is 30. And then from there, we can solve this equation with variables on both sides. I'm going to move the 40v over to the right-hand side. So then I've got 70 equals 50v plus 30. And then I'm going to move the 30 from the right-hand side over to the left-hand side. So I have 50v equals 40. And then, to finish this out, all I have to do is divide both sides by 50. So I get v equals 40 over 50. Simplify that, I get 4/5. If you use your calculator and get a decimal, you're going to get 0.8. Both answers are fine. All right, so that's how you can use cross products to solve some more complicated proportions. So go ahead, I'm going to pause the video, practice these 3, and then check your answers. There's the work for those proportion problems. So make sure pause the video and check them all. Make sure your work matches, and if you have any questions, make sure to ask. The last thing to wrap up this video is some application problems involving proportions. So at a book sale, 6 books cost $13.50. At that rate, how many books could you buy for $35? So when you set up a proportion using application problems, you want to look for the ratio that you know. You know 6 books cost $13.50. In this ratio, the tops is books, the bottoms is money. So when you know this, you know $35, that's going to be on the same end as your money, and then you're trying to figure out how many books. That's your variable. So books is on top. Okay, so there's your proportion, and now I'm going to cross multiply. So I have 6 times 35. So 6 times 35 is going to give me 210. So if I do that cross multiplication, it's going to give me 210. And then this right here is going to give me $13.50 times x. So then to finish out this problem, I'm just going to divide both sides by 13.5. And x equals 15.5 repeating. Now, how many books can you buy? Well, now I'm stuck in between 15 and 16 books. But if I think about relating this answer of 15.5 repeating back to the context of the problem, you can only buy 15 books for $35. Because you don't have enough money to actually buy that 16th book. Now, the other type of application problem we could use is kind of a scale factor. So when they make maps or model buildings or anything like that, you're using a scale. So on a map of Florida, the distance between Jackson and Tallahassee is 2.6 centimeters. If 2 centimeters equals 120 miles, so there is a ratio that I know. Centimeters on top, miles on the bottom. So if 2 centimeters equals 120 miles, what's the distance between the two cities? Well, we know this fact. We know on the model, on the map, it's 2.6 centimeters. We're trying to figure out how many miles it is. So I want to cross multiply this proportion now. So I'm going to have 2x equals 120 times 2.6, which is 312. If I divide both sides by 2, x is going to equal 156. So Jacksonville, and Tallahassee are 156 miles apart. So, go ahead to close out this video. Got a couple more practice problems for you just so you can double check to make sure you're understanding the application process. All right, you can double check your answers here. One thing that I'll make sure that you set up when you have an application problem is that the tops of your ratios are the same thing. The bottom of your ratios are the same thing. So what I mean by that is you'll notice the red proportion. The top, the numerators in both of your ratios, those both were years. The denominator in your ratios in the red both refer to the stores. So make sure you are being careful in how you set up that proportion. Okay, that's all I got. Make sure you practice the worksheet and get your work done.